Hello. The last time I left you, I showed you how to write and name ionic compounds. I want to be a little more specific today, show you something a little bit different. The ionic compounds that I showed you how to write last time, those were called binary ionic compounds. If you think about the word binary, you guys all know that means two. So in this case, it just means two elements. Now be careful, it doesn't necessarily have to be one of one element like sodium and one chlorine. It's just two elements, like right here, iron oxide. It's iron and it's oxygen in this compound, so we call that a binary, even though the ratio is 2 irons for 3 oxygens. So binary just means two elements in the compound. What we're going to do today is called ternary ionic compounds, and ternary would be more than two. You're going to have at least 3 elements in these compounds, and here are some examples. Right? So you got calcium here, and you got a sulfur, and you got 4 oxygens in this compound. Right here you got sodium, and then phosphorus, and 4 oxygens also. So there's some examples of some ternary ionic compounds, more than 2 elements. I'm going to show you how to write and name these today. And obviously oxygen is a very big deal. You're going to see oxygen a lot in these compounds. So our ICAN statement, I can write the name and chemical formula of a compound that contains a polyion. That's how you become a ternary ionic compound. You have a polyatomic ion, and poly meaning more than once, more than one. Okay. Now what I want you to do is I want you to write down these polyions here. Okay. NH4, and then write a little plus sign outside of it. C2H3O2 with a little minus, and make sure you have this correct charges with these. But take a moment, write all these polyions down, and then go to page 210 in your book. I need you to find the name of each one of these polyions. You are going to be responsible for knowing these. And I can tell you right now, you're not going to find PO3 with a 3 minus charge in there, but it is called the phosphite. I'm going to underline the ending here, phosphite. Big important thing here. Big important thing. Pay attention to the endings of these words, because that's going to be very important when we go to name these things. I can't stress that enough. Pay attention to the endings. Take a moment, write these down. Alright, so now we need to write the name and chemical formulas. I have examples here all ready to go of what I want you to want to show you. You're going to see this looks very familiar than what you already know. So in this case, sodium forming a compound with SO4, which is sulfate. Okay. So Na and SO4. The first thing, you need to know your charges here. That's why I need you to have this stuff written down. Sodium, if you look on your periodic table, you should be able to get that its charge is +1. Sulfate's charge, the whole thing is -2. I want you to put parentheses around the whole SO4 and then have your -2 outside of it, okay? Because the -2 applies to the whole thing. And why that's important is when we do our crisscross, our crissing down here applies to the whole thing in the formula. So we have +1 to write this formula. We crisscross. That 1 goes down there. That 2 goes right there. And we rewrite this. Na2 it's 1 sulfate, 1 SO4. You know that chemists don't like to write ones. And here's the thing, when your polyion has just one of them, the chemists do not like to write the parentheses. So they would write that as Na2SO4. And that's the chemical formula. Now the way you name this is, you know, it's the name of the cation followed by the name of the anion. So we start here, we got sodium. And sulfate. Name of the cation sodium, name of the anion is sulfate. It's called sodium sulfate. And it is that easy. Do me a favor. Be very careful about the endings. This is going to be very important. Okay? Next one, we're going to do magnesium and sulfate combined together. Charge is magnesium. You need to know how to get that this is +2. Your sulfate. Parentheses. Charge outside applies to the whole thing. Do the crisscross. Mg2SO42, but we can reduce this. Always reduce ionic compounds if possible. So you're going to just reduce this and this. I don't want you to touch what's inside the parentheses. I really want you to, when you start these things, always put your parentheses so you know that that's like its own separate entity. You cannot touch the 4 oxygens in there. They have to stay there like that. So the way you would write this without by reducing it, it's just Mg(SO4), because when there's one SO4, we're not going to put parentheses. So that right there is the chemical formula. And then to do the name of the cation followed by the name of the anion. Magnesium sulfate. Next one here, we'll do magnesium, and that right there, NO3, is the nitrate ion. Magnesium, once again, is +2 charge. Nitrate, NO3. Put parentheses around it. You need to know the name of that, and the charge is -1. So now we're going to crisscross to write our formula. So now it's 1 magnesium, our nitrate, there's 2 of them. So now I have to write the parentheses. If I don't write the parentheses, it's like the 2 only applies to the oxygen. But it's just like in math, the way you distribute with parentheses, 2 applies to the oxygen to make a total of 6 of them, and 2 applies to the nitrogen, so you have 2 of those. So you put parentheses around the whole thing. And what I just told you right there, it'll be very important to understand that when we learn how to balance chemical equations. Last thing here, writing the name of this, name of the cation, followed by the name of the anion. This is called magnesium. magnesium nitrate. And I want you to do the last one on your own. Show it to me when you come into class tomorrow. We have aluminum and PO3, that is phosphite, right down here, and it has a -3 charge. All right. So good luck, we're going to practice a lot.